Today, I thought it would be a good exercise to try and create a clock from start to finish that works in geometry nodes. So with that, let's actually begin modeling this clock and seeing how we can get it to match real time. So in our default scene, we're going to bring our cursor to the junction of these two windows, click and drag to create a new window, and we'll change it from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree. We'll zoom in, select the group input, and tap X to delete it. Now remember, for this clock, the first thing that we want are the actual hands of the clock to actually match with the time in real life. So I'll search for a curved line and I'll plug this curved line into the group output so that we can actually see it. And right now it's going up on the Z direction. So let's assume this is the second hand. We want it to go on the Y axis. So we'll change the end from a value of 1 on the Z to a value of 2 on the Y. So that way we get a 2 meter long line on the Y axis. Next, we actually want this to rotate. So we're going to search for a transform geometry node and we'll plug that in after the curved line. Now let's take a look at what rotation values should work to get this to turn every second. Remember, we can get the seconds by searching for a scene time node and directly using this seconds value over here. But remember, if we plug this into the rotation, we're not going to get anything close to what we want because right now it's rotating on firstly all three of the axes by the same value, and that's clearly not what we want. We want it to rotate about the Z axis only, and apart from that, this is giving a value out in seconds, but we need to convert that to radians because the input to this rotation socket is in radians, and we want it such that for every second it turns by a total of 360 degrees divided by 60 degrees. So let's take a look at why we're doing that as well. If you take a full circle, the full circle is a total of 360 degrees. Now, one full circle corresponds to 60 minutes. So therefore, 1 minute would be equal to 360 degrees divided by 60 minutes, which implies 6 degrees per minute. So hopefully that was very basic math and you understood that 6 degrees for every minute should work. And also the same thing works for seconds because it's one full circle for 60 seconds as well. So let's go ahead and do that now. For 1 second, we want it to move by 6 degrees. So all we have to do is search for a math node and then multiply the second value by 6. So if we change this from add to multiply, we can directly put in the value of 6. And now if we were to directly plug this in, we wouldn't get what we want because we've currently calculated this for degrees and this rotation input socket takes in radians. So let's search for another math node and this time change it to radians over here. And now we can just plug this in and plug this into the rotation value. But remember, again, this is giving the same value on all three of the axes. We want it only about the Z axis. So I'll have to search for a combined XYZ node, plug that in after the 2 radians and plug this into the Z's value. That way we get this to rotate about the Z by 1 degree every second. However, the problem is that it's going in a counterclockwise or anti-clockwise way. We want it to move in the opposite direction. So to do that, all we have to do is search for a math node and we'll change this to multiply and we'll multiply it by a value of -1. And that way it should be rotating in the correct direction. Now for the seconds counter, I don't want it to move in a smooth way like this, although you could if you wanted to, but I want it to go in steps of every 1 second. That means only once it reaches 1 second should it just click. So it goes tick, 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 tick. So to get that, all I'm going to do is search for a math node and I'm going to set this to round. So that way it'll remain 0 until it reaches 1. And once it reaches 1, it's going to switch over to the next value. And that will work better if I keep it at floor. And that way it'll wait for 1 whole second and then it'll tick to the next second. So let's plug that in here. And now you can see it ticks perfectly according to the time. And since we're using the scene time seconds, the frame rate does not matter. We could change this to 30 frames per second later on. We could change it to 60 frames per second, but it would tick once every second itself. So that's perfectly all right. And we get something that looks really good. However, we need to duplicate this entire setup for our minute hand and for our hour hand. So let's just make everything a little bit more organized and then just select all of them, press Shift D and just move it up. Now this one we're going to do for our minute hand, and remember 1 minute occurs every 60 seconds. So essentially all you have to do is remove this floor because I want the minute hand to move smoothly, and then since it should be going slower than the second hand, I'm going to search for another math node, change it to divide, and I'm going to divide the seconds value by 60, and then I'm going to plug that into the multiply value. And now if I go ahead and watch the animation, we don't see a difference because we haven't actually added in the minute hand to the node tree. So I'll search for a join geometry and then simply plug this into the join geometry, and now we have a minute hand as well that moves accordingly. Now since we have only 250 frames, we don't see enough of the motion, so I'm just going to change the end value to something really high, let's say how long ever that is. And now I can just drag this to the end, and you can see that by the time this finishes 1 full rotation, 1 minute would have passed, so the minute hand is here. Now if I go to the next frame, it should almost align at least, or the next 30 frames, it should almost align because it is 1 second after that, which is perfect. So that means we're actually getting this to work properly. Our minute hand is also working right, but we don't want the minute hand to be as long as the second hand. We know that the minute hand is generally shorter, so I'll go ahead to the curve line over here and change this end value from 2 to maybe 1.75, and now it's just a bit shorter. Next, we need to create the hour hand, so I'll just take all of these, press Shift D again, bring it up, change the Y value on the curve line node to something like 1.25 because the hour hand is generally very short. Then I'll change this divide value from 60 to 360 because remember, there's another factor of 60 occurring, so it should actually be 3600 because it's 60 into 60. So if we add that in and then plug this into the join geometry, we should get an hour hand that also works perfectly. Now we have a second hand and an hour hand that actually works according to real time. So that's great, but we have to actually give these lines some thickness because right now if we just switch off overlays, nothing will be seen. So to give these some thickness, we can choose to convert them to a mesh after the join geometry, and that way each of them will have the same thickness. But if you want them to have different thicknesses, such as the hour hand could be a little thicker than the minute hand, which could be thicker than the second hand, we can do that before we use the join geometry itself. So let's just shift this a bit to the top, press Shift A and search for a curve to mesh node, plug that in right after the first transform geometry. For the profile curve, I'll press Shift A and search for a curve circle. I'll reduce the resolution down to something like 4 and I'll change the radius to 0.08 maybe, and then I'll plug this into the profile curve, and that seems a little too thick, so I'll reduce this down to 0.02. Then I have to do the same thing for the minute hand and the second hand, so I'll take these two nodes, press Shift D, plug them in here, plug this into this and remove this connection and connect this into this. Next, resolution I'm going to keep at 4 itself, but I'm going to reduce the radius to maybe 0.015 so that it's a bit thinner than the hour hand, after which I'll do the same thing again, Shift D, bring this down here, connect this to this, remove this connection and connect this to this. Then change the radius down to 0.01, and that way we have the 3 hands that are moving like a real clock. Next, we need to actually add in the numbers, so we know that what these arrows are actually pointing to. So for that, we'll shift the group output to the side and search for another join geometry node, plug that in over here, and I actually want to make all of the numbers and plug that into this join geometry directly. So I'm going to take this join geometry, press Shift D and create all the numbers down over here. Now for the numbers, we know that there's going to be 12 numbers, so I can place that on a curve with 12 points. So I'll search for a curve circle and I'll reduce the resolution down to 12 so that there are 12 points. Now to actually see this, for the time being, I'll just plug this into the join geometry up here so that we can see it, and then we can set the radius accordingly. So I want the radius to be larger than the second hand, so I'll increase it till it comes outside the second hand. So I think a radius of 2.4 is good enough, but I need some space for the numbers to actually be there, so I'll make it 2.5. Now I have to actually instance a number on each of these points. So to instance on points, I can search for an instance on points node, plug that in after the curve circle, and for the instance, I'm going to press Shift A and search for a string to curve node and just plug this into the instance. If I now change the string to something like 12, we'll see 12 occur on every single one of the points, but it all seems shifted, and that's because we have to change the alignment from left to center and top baseline to middle, and now they're actually going to be on the points. Next, you can choose whatever font you feel best, so select this and go to your Windows fonts folder and choose a font. So I went with Arial Bold for this animation. Next, we don't want it to be on every single one of the points, we want it only on this particular point. So for that, we have the selection input, so I'll press Shift A, search for an index node so that we know the indices of every single one of the points, and we want to compare if the index is equal to the right index, only then do we want to instance the point. So I'll search for a compare node and I'll change this from float to integer because indices are always integers, and we want to check if it's equal to a specific number. Let's plug this index in here and plug this result into the selection. Now we see it goes only to index 0 and index 0 is over here, but that's not what we want. We want it up here. We just play around with the index until we get it to the right place. So an index of 3 brings it to the right place. Now essentially I want this exact setup for all 12 of the digits. So I'll just hide all of these nodes by pressing that little arrow mark to collapse them, and then just make it a smaller setup. Take this curved circle and drag it to the side over here, after which to copy all of these with the connection intact, we can just select them and press Ctrl Shift D, and that way this connection also remains, and we can simply connect this to the join geometry and plug this also to the join geometry, and then plug this into the join geometry up here. So let's take this, plug it in, and we can remove this connection over here. Now for each number, we're just going to change the string. Let's say after 12 we want it to be 1. I'll change this string to 1, and then to place it properly, I'll go to the equal to and just change this until we get it to the right place. So in this case, a value of 2. After which again, select these, Ctrl Shift D, bring it down, connect this up here by pressing Alt and click. We can drag this down as well so that it's easier for us to make that connection. Change the strings to curve from 1 to 2, and then change the equal value to the value that seems right. Then let's do that again. Ctrl Shift D, strings to curve will change 3. This is going to get plugged in over here, and then the equal to value is going to change till it's right. Now I'm going to do that for all of the other numbers and come back. Just to mention, apart from changing this every time, what you could do is Control Shift D, and this would be for number 5, Control Shift D number 6, number 7, number 8, number 9, number 10, and number 11, and then just zoom out and connect these up, and that way it just is a lot faster than doing it individually. And remember, this particular shortcut of Alt right click is from the Node Wrangler add-on, so you have to enable Node Wrangler add-on from your preferences, and then you can go ahead and change all of them accordingly. So once all of that is set, you can go ahead and convert these also from curves to actual meshes by pressing Shift A, searching for a fill curve node and plugging that in. Now they have no thickness whatsoever, so to give them some thickness, you can search for an extrude mesh, and then you can change this extrude mesh offset scale from 1 to something smaller, let's say 0.1, and you can switch off individual. Now at the bottom there is no face, so just to fix that, you can press Shift A, search for another join geometry, plug that in over here, and take this fill curve, search for a flip faces node, plug this in here, and plug this out here just to fix the normals, although that doesn't make a difference in our particular animation. It's just better for many other situations, so we'll keep it like that. Next, we have all of these. What we could do from now itself is start labeling everything so that we don't lose track of what is what. Let's take all of these nodes, press Ctrl J to add in a frame, come to the node tab over here and label this as numbers. Then let's come here, select these, Ctrl J, call this the seconds hand, and do the same for the minute and the hour hand as well. Next up, we need some sort of a base for this entire clock to be present on. So I'll again take this join geometry, shift it over to the side, and press Shift D and plug it in. Of course, you could add everything into the same join geometry, but I want to keep all of these separate so that it's much more organized. Now for the back, I'll press Shift A, search for a mesh circle, and since I want the entire face to be present, I'm going to change the fill type from none to n-gon, and I'm going to increase the vertices to something high. Let's go with 256 to make it nice and smooth, and then plug this into the join geometry. Now it's clearly too small, so I'll increase the radius till all the numbers are covered. So I'll go with a value of 2.8. It's still too small, so to go to the top view, I'll just press numpad 7, and you can see that the 10 is still getting cut off. I'll increase the radius to 3. Then I want this to also have some thickness, so I'll press Shift A, search for an extrude mesh, plug that in. But now if it extrudes in the positive axis, it's going to cover our numbers. I'm going to actually change the offset scale to -0.1, and that way the thickness is in the bottom direction. However, of course, we need the plane to also be present on top, and it shouldn't be hollow. So I'll press Shift A, search for another join geometry, and this time, since we off scaled it in a negative direction, we don't need to flip the faces. We can directly plug this in, and we have it correctly. Next, all of the numbers will be perfectly seated on the plane, and you can see how the hand is getting cut by the plane. So I'm actually going to just shift the plane down a little bit by searching for a set position node and just changing this Z offset to -0.1, and that way it just comes down by a little bit and nothing is getting cut by the plane. I think 0.1 is a little too much, so I'll change it to 0.02. Now that we have all of that set, we need to actually add in the glass covering. So again, take this join geometry, press Shift D, plug it to the side, then press Shift A, search for an icosphere. Now I'll give the radius the same radius that I gave to this mesh circle, which is a radius of 3, and I'm going to increase the subdivisions to something like 5 so that it's really smooth, and then plug this into the join geometry. Now we don't want this to be a perfect sphere, we want it to actually be squished on the z-axis. So I'll press Shift A, search for a transform geometry node, and I'll just scale it down on the z-axis until it becomes nice and flat and looks like a dome glass covering for a clock. I think I'll go even lower, and that seems alright. However, I don't want the same thing to be present on the bottom sphere as it is right now. I want only this top half to be present. So to keep only the top half, I can search for a delete geometry node, plug that in after the transform geometry, and for the selection, I can actually take the position of every single one of the points, check which positions are lesser than a value of 0 on the z-axis, and then delete them. So I'll search for a position node, which will give me the position of every single vertex of this icosphere. Then I'll search for a separate xyz so that we have only the z-axis value. Then I have to compare this z-axis value with some value, so I'll search for a compare node, and if it is lesser than 0, then I want it to be deleted. So I'll change the greater than to less than, and I want it to be less than a value of 0 to delete it, and then I'll plug this into the selection. Now even though it's less than 0, there's a little bit of gap, so I'm going to change this from less than 0 to less than 0.1, -0.1. So that way we get the glass dome, it's deleted on the bottom, and that seems alright. So again, it's best to just keep all of these nodes organized. So let's just do a little bit of organization and then continue. Now that we have the glass dome and the back plane created, we need to create a small little stop for all of the hands to actually connect to. If you actually hide the glass dome for now by just selecting this icosphere and tapping N, we can actually see that these particular hands are coming from this central region, and that doesn't look too good. We need something to be present over there. So I'll just press Shift D, search for another join geometry, search for a cylinder, plug this mesh into the join geometry, reduce the radius down to something like 0.1, and decrease the depth as well. Then I want want these vertices to be increased to 256, so that's really nice and smooth, and that seems alright for my clock. Now that I have everything present here, I need to go ahead and finish off the node tree by adding in sockets for every single one of the materials and also shading smooth. So after everything, I can search for a set shade smooth node, plug that in, and now everything's going to be nice and smooth. And then for each of these, I need a material. So I'll go to my material properties over here, press this plus button to add in as many slots as required. Remember, I need one slot for the back plane, one slot for the numbers, one slot for the hands, one slot for the dome or the glass dome, and one more slot for the actual screw present in the center. Then let's change the names. So I'll call this back plane. This next one, create a new material, call this hands. Next material, new, call this screw, and do the same thing for all the other materials present. So I need something for the numbers, and lastly I need something for the glass dome. Then I'll press Shift A and search for a set material node and plug that in after each section. So for this, remember these are for all of the hands. So I'll go ahead and choose the hands. Then I'll take this set material, press Shift A and plug that in over here. And remember, this particular side is coming in from the numbers, so I'll change this from hands to numbers. Then again, press Shift A, search for another set material, or you can just duplicate the other one by pressing Shift D. This one is for the back plane, so I'll choose back plane. I can unmute this by tapping M again, press Shift D, this in here, change this one to glass dome, and then again do the same thing. Take this set material, Shift D, plug it in here, and call this the screw. Once we're done with that, we can set all of our material defaults and start with the texturing. So let's go to our out properties or render properties, switch on ambient occlusion, bloom, screen space reflections, and under screen space reflections, make sure you have refraction check for the glass dome to work properly. Then change this from the geometry node editor to the shader editor, and the first thing that we'll deal with is the glass dome. So if glass dome isn't there by default, come here and select glass dome, because we need to be able to see through the glass dome for us to actually work with the rest of the materials. Also, to see changes, change from the viewport shading of solid to a viewport shading of render. Now go down to the settings on the material properties and change the blend mode from opaque to alpha blend, switch the shadow mode to none, switch off show backface, and check screen space refractions. Then if you can't see the nodes over here, press period on your numpad to centralize the nodes, select the principal BSDF and tap X, then press Shift A, search for a glass BSDF and plug this into the surface, and that way we just get this glass dome, and I think the default is good enough. Now I don't actually want any shadows to be formed by any of these digits, so on the light I'll just uncheck shadow, and that way no shadows will be formed. What you're seeing is the refraction onto the glass plate, which is good enough, because most of the time it'll be from the top view directly like this, and if we go to the edge, we want there to be some sort of refraction so that you can tell that yeah, there is a glass present on top of it. So that's good enough. Next, again, select this object and start off with maybe the numbers. For the numbers, I'm just going to make them have a base color of black and a really high roughness so that they're solid numbers. Then for the screw, I want it to be metallic and I want it to be slightly golden, so I'll change the base color to that goldenish color, and I'll reduce the roughness as well down to maybe 0.3. Then I'll select the hands, change the base color to black again, and that should be all right. Then for the back plane, I'll just add in some sort of abstract design. So I'll press Shift A, search for a wave texture, and I'll connect the wave texture's vector to a noise texture. So press Shift A, search for a noise texture, plug this color into the vector and this color into maybe the roughness. Then I'll change the metallic value all the way to something like 1. And then just for better control, I'll press Shift A, search for a color ramp, plug that in over here, and I'll change this black from a value of 0 to a value of 0.2 so that it's not completely reflective. And this white, I'll change from a value of 1 to a value of 0.7 so that it's not completely non-reflective. Then the scale on the noise texture, I'll reduce down to maybe 0.5, and that just gives it this abstract look. Maybe I'll punch in the values a bit. I think that looks good for me. After which I'll give this base color maybe a slight bluish tint. I think that looks good. Next, my light is way too sharp, so I'll go to my light, go to the radius and just increase that up quite a bit. And with that, I'll have to increase the power as well, so I'll increase the power to something like 5000, and that's nice and bright, so I think that works out. Next, I feel like this entire clock is missing some sort of a border, so I'll add in the border by going back to my geometry node tree. After everything, just before the set shade smooth, I'll search for another join geometry, or I'll actually connect this on top. So I'll press Shift A, search for a curved circle, plug this into the join geometry, increase the radius up to 3 so that it's at the edge. Then I'll search for a curve to mesh node, and this time for the profile curve, I'll search for another curved circle, but I'll have to change the radius down from 3 down to something like 0.2, and then plug this into the profile curve. Now we have that. I think even 0.2 is a bit too fat, or I'll increase the radius from 3 to maybe 3.2. Then I'll just increase the resolution on all of them, make this one 256. This one doesn't have to be this high, maybe 64 will be good enough. And then I'll set a material for this as well, so I'll just this to the side, search for the set material, or take this one and press Shift D, plug that in here. I need a new material for it. Although the gold also looks good, I think I'm going to go with silver, so I'm going to press this plus button, call this as the edge ring or border, and then I'll choose border from here. Then I'll go back to my shader editor. For the border, I'll just go ahead and increase the metallic value all the way to 1, reduce the roughness from 0.5 to 0.4, and I think that's good enough. That is my clock. Now for the actual rendering, remember, if you want a specific section, just go to that section. So let's say you want it to be rendered from 1 o'clock for a few seconds. So just play around with this till you get to 1 o'clock, and once you're there, just change the start frame to that, change the end frame to wherever you want it to be, and then render out that many frames. But essentially, that's it for animating the clock as well. If you want some background, like what I did, is just go to the world properties by changing this from object to world, and then I've kept the background as this itself, but I pressed Shift D to duplicate it and change this one to a bright white, and then I searched for a mixed shader node, plug that in over here, and for the actual factor, I used a light path node, which is the same technique that we've used in multiple videos before, so that if it's a camera array, it's going to take the white value, but for the entire shading, it's going to take this grayish value itself. So again, that's up to you how you want to use it. If you don't want this background to remain this grayish color, you can always go to the color management down here and change the view transform from filmic to standard, and that way the white becomes actual white. You can play around with the light settings as well to get it to what you like, and always you can select the camera, press Alt G to clear location, Alt R to clear rotation, then GZ to bring it up, then press 0 to go into your camera view, GZ to centralize it or zoom in as much as you want, and then once you're happy with everything, go to the output properties. Make sure you don't forget to change the output folder to wherever you want it to be, and the file format to FFmpeg video, change the encoding from Matroska to MPEG-4, and an output quality of perceptually lossless. Then render animation. I know this one might have been a bit longer than usual while remaining way too simple to be this long, but the fact that I wanted to show through this video is that, yeah, if you do have an idea, you could technically go step by step and create something with a lot of different parts and different requirements all within a single geometry node tree. It's fairly simple, and I'm sure you'll be able to create the exact same and use these techniques for other situations as well. If you've watched so far, thank you so much for watching. I post videos every single day, so I'm sure there's other videos present on the channel that you will definitely find useful. So until the next video comes out tomorrow, keep creating and stay creative.